Personal finance practice problem using Excel. Excel functions, present value, future value, and number of periods. Get ready to pursue personal financial fitness by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. We have the information on the left-hand side. We're going to populate that into the blue areas on the right-hand side. Note that you may or may not have some hidden cells up top. We're going to first practice hiding and unhiding some cells so we can see what we did last time and continue on with our practice problem with the same scenarios. So you can see up top we got A, B, C, and then it skips on over to L, which is not how the alphabet goes. So there's going to be some missing columns there. So I'm going to unhide some columns and then rehide them just to show how to do this. What we want to do is be selecting from B to L. I'm going to put my cursor on B so I have this drop down, or left click on it. I'm going to drag on over to L. And so we've selected those whole columns, not just the cells, but the entire column. Then right click on the selected area and unhide those columns. I'm going to unhide that. Now we can see what we did last time, which was the rule of 72 and then this running balance. So the scenario that we looked at was to assume the value of the property increased at a rate per year of 7%. And then we asked how long would it take then at that rate for something to double. We looked at it first by not even having an investment account, applying the rule of 72 to get to the 10.29 years. That's an estimate. Then we assumed an investment, which I think is more intuitive for most people to do, and ran a running balance to kind of estimate that same number to get somewhere between 10 and 11 period. Now let's do the same kind of thing, but this time using the functions in Excel. And it's really useful to use the Excel functions. They can be quite intimidating at first, but notice that this rule, like the rule of 72, is quite restrictive. It's only telling you when something doubles and whatnot. If you want something more complex than that, you can use functions in order to do that, or other methods. And those other methods are quite easy these days as compared to the past, given the functionality of something like Excel or other similar spreadsheets. Let's go ahead and hide the cells up top again. Practice doing that. We're going to put our cursor from column D. I'm going to bring it on over here to K. So I'm going to put my cursor on column D, drag on over to the K, and then let go. And you don't have to do this, by the way, but it's easier to do. I'm going to right click on the selected area, and let's go ahead and hide those cells. And this allows us to work with our data right next to where we're going to be putting our information. So we're going to have the same kind of thing we want to do with functions. Now, the first two functions you'd probably learn are going to be the future value and present value functions. These functions are going to be related in nature. And with this question, we could use those two functions to find basically what we're looking for, which is going to be the number of periods. So let's actually start off with those, doing these two functions and backing in to the unknown, which is the number of periods that we're looking for, which will be how long it would take, in other words, for the investment of, say, 1,000 to get to 2,000 if we had a 7% interest rate. Now, if we did this mathematically and we had the mathematical formula, then typically we can take the function of something like a present value algebra and solve for the unknown, which would be the number of periods here. And we would rework the algebra, and we'll actually do this in a second presentation. But first, let's think about this in terms of a function. With a function in Excel, we can't really rework it as well with the algebra, but we can still use a similar kind of method to find any unknown that's in the function by using something called goal seek. So in order to set this up, let's go ahead and basically put something down here. I'm just going to assume or guess it's going to take 5 years as our starting point. And once we enter the calculation into Excel, I'm then going to change this number, or ask Excel to change it to whatever it needs to be to make the end result be what it should be. And that way, using the algebraic concept of basically if I only have one unknown, I can back into whatever that unknown is. So let's take a look at this. I'm going to go through the functions a few different ways. One way we can do it is I'm going to put my cursor in this cell. We want to go to the formulas up top, and then go to the insert function on the left-hand side. This will give us a dialog box, which can be a little bit easier sometimes to help us populate the function. I'm looking for a future value, which I could type in like this, and sometimes it doesn't find it, or FV. I know that that's the function. There it is. It gives us a description down below. It gives us returns the future value of an investment based on the periodic constant rate and consistent interest rate. I'm going to say, okay, that's the one. We get our dialog box. So here's our dialog box. Now this dialog box will be the same whether we're talking about future value of an annuity or future value of just one, and then we're going to have to change our input between the two. That's useful, but also a little bit confusing. We'll do multiple practice problems, so hopefully you'll get used to that. So we're going to pick up the rate, and I'm going to pick up the rate all the time, just like with our prior problem, from the data set as much as possible. So I'm going to pick up that 7%. Then I'm going to put my cursor in the number of periods. Notice it gives you a nice little description down here as well. Number of periods, that's the one that we don't know. That is our unknown. But we're guessing what it is to start off with so that we can then change it later. So I'm going to say, I'm going to pick up that 5 that's in this cell that I set up simply so I can change it. I don't want to hard code it, meaning simply type in a number, but have it in a cell so then I can ask Excel to change that cell to whatever it needs to be to figure out the function. Now, this is the tricky part. There's no payment that's going to be involved here because that payment relates to an annuity, as if there was a series of payments. We don't have a series of payments. We're talking about one investment that's going to basically just be growing over time. We're not putting another investment in of $1,000 each year, for example. So we skip that one. We're going to say the present value is this $1,000. That's going to be the $1,000. And then once I say, okay, it's going to give us the result down here, which is shown. Notice 1,403 that we're going to want. Now, what I expect this to be, what I would like it to be, is 2,000, because we want this to double, meaning from 1,000 to 2,000. It's not going to give us that because we don't have this input to be correct. Then we'll go back and change this input. So I'm going to say, okay, there we have it. Now, a couple things. One is this 1,403 is negative, and two, I want it to be a positive 2,000. So I'm going to double click on it. One way you can change the sign, Excel kind of wants you to put a negative number on the number of periods, but usually for these future and present value ones, I just put a negative, and I think it's just handy to know. It's useful to know that if you put a negative before most kind of functions, it basically takes that function, flips the sign, or in other words, multiplies it times -1, flipping the sign. So that then makes it positive. Notice also, you could type this function in this way with this nice little dialog box. So let's go ahead and do that. I'm going to actually type it in this way just so we could see both ways of typing this. So I'm going to delete this. I'm going to say equals future value. And this is the fastest way, the way you will default to after you get to know a particular function. Double click on that function. There's our equals function, FV, the brackets indicating the function, and we got this nice little box down here which will indicate each set of the function, dividing it out by a comma. So then I would pick up the rate, which once again, I'm not going to type in. I could put 0.07. That's what I would call hard coding, just typing in the number. I don't want to do that as much as I can. I want to pick the number up from the data set so that I can then change my data set to make projections in the future. It's just good practice to do. And then comma, it moves then to the number of periods, the next in our dialog box. The number of periods is the unknown that we set up down here in our nice little box that's going to be 5. That's the thing we'll change later. Then I'm going to say comma to get to the next argument, which is the payment. Now, there is no payment. This is the tricky thing when we're using present value, future value formulas, because it has the same formula for an annuity and a present value of 1. This is not an annuity, meaning we're not making multiple $1,000 payments, but we have the same $1,000 that is increasing over time. So we can either put 2 commas just in a row, taking us to the next argument. Sometimes when you're learning, it's easier to put a 0 there just as a placeholder. You can do that if you feel to get us to the present value. The present value is 1,000. We want that 1,000 then to be 2,000 at the end of the day, and it won't be because it's going to be dependent on this function. So I'm going to say, okay, now I'd like to flip the sign again. So I'm going to double click on it, put my cursor in front of the F. Also know the function is up here as well. So if you're moving around in Excel, you can see it up top too. Put a negative in front of the FV and then enter, and that flips the sign to a positive number. Now I'd like to change this cell until I get this number to be correct, which I could do manually by putting a 6 here, putting a 7 there, and so on. Or I could ask Excel to do that by going up top and saying, let's go to the Data tab. And this is a really useful function. Not a lot of people know about it, but it's really useful to do. So once you have everything connected here, and I just want to change this unknown to make that function correct, I could go to the Forecast section in the Data tab, Forecast Group, What If Analysis, Goal Seek. We're going to seek a goal. We get this little dialog box. Notice I'm not on the cell that I want to change. This is the cell I want to change. I don't need to be on it in order to change it. And then I'm going to go to set this cell. I want to make this cell be what I know the answer should be, which is 2000. That's what it should be if that 1000 was to double. So I'm going to go down here. You have to hard code the 2000. I can't put 1000 here times 2. I have to actually hard code this, and then, which means type it in there, hard code. And then we're going to go down here by changing this cell. So I want you, Excel, please change this cell to whatever it needs to be to make that cell what I want it to be, which is 2000. So then we're going to say OK, and Excel just kind of forces it to work, and there it does it. There's the 10.24. It does it with brute force instead of changing the function. So that's one way you could do this if you know a function, for example, and you don't know one of these unknowns in the function, which in this case we didn't know the number of periods. The other way you could do it, which we'll take a look at later, is look at that number of periods and see if Excel has a function, which it does, for the number of periods, which we'll do last. So you could do that as well, but you may not be as familiar with that function as you are with, say, the present value or future value, and it's useful to know how these things are related. Because notice we could do the same thing down here with the future value function and make the same kind of argument. I can assume down here, once again, for example, that I had 6, and I could say, well, can I do a future value calculation if I know the investment amount, the end amount, which is 2000, and the percent? Let's do the same argument using a present value. Sorry, there's a present value one. So I'm going to put my cursor on this blue cell. Let's do it the 2 ways again. We're going to go to the formulas. We're going to go to the functions, insert function, dialog box. I'm just going to type in present value this time. And that's going to return the present value of an investment. So I'll say, okay, that looks good. Okay. Dialog box, set up. All right, dialog box. Here we have it, the rate. Once again, I'm going to pull the rate over here. I could put 0.07, but I don't want to do that. I want to pull the rate from the cell in the data group. Number of periods, that's the unknown, which we guessed to be 6. So we're going to guess it at 6. That's the one we're going to change again. Once again, there's no payment this time because we're not talking about an annuity. We're talking about one present value of 1. And then the future value, here's the change, here's the different thing here, is not going to be simply 1000. It's going to be 2000 because that's what it would be if it was to double. So I could just type in 2000 here, but I would like to take as much as possible from this data set as we can. So it's just good practice if I want to use that data set in the future to change the numbers and then run scenarios. So I'm going to pick that up times 2. So there we have it. Notice it's a negative number down here again. So I'm going to say, okay, there we have it. It's a negative. I usually like to flip the sign by double clicking on it, going back into it, going before the P, and then I'm going to put a negative before the P, which in essence multiplies it times -1, flipping the sign, and okay. So there we have that. Let's do the same. Now, what I would like that to be at the end of the day, if it's going to be the present value, it should be back to 1000. So I can use the same goal seek to figure this cell, change this cell, Excel, please, so that this cell will then be at the 1000. But before we do, let's do this calculation again using the dialog box, which is what you will use, or just a normal function, which is what you will use once you get used to this because it's faster. So I'm going to delete it. I'm going to put my cursor back into it, type in equals present value, and then I'm going to double click on the present value here. We have our same kind of set of arguments. The first item is going to be the rate. So the rate is going to be that 7%. I'm not going to type it in there, but pick it up from the data set, comma, number of periods. That's the unknown that we set up down here. And then I'm going to say comma, which takes us to the next argument, comma, the payment that we have. There is no payment because the payment relates to an annuity, which has a series of payments plus the interest. This is just the interest only. So I could either put 2 commas, taking us to the next argument, or we can put a 0 and then a comma as a placeholder. And then the future value is going to be 2000, because that's what it would be when it doubles. But I'd rather take this cell times 2 so that I can pick it up from the data set as much as possible. Closing that up and then enter. There it is again. It's a negative number. I'd like to flip the sign, double clicking on it, putting my cursor before the P. I'm going to put a negative before the P and enter. So there we have it. Now I'm going to ask Excel. I'm going to say, Excel, could you change this cell to whatever it needs to be to get that cell to be the present value of 1000, which we could do by default. This is all Excel's going to do. It's going to say, well, I don't know, let's try 8. Let's try 9, and it's just going to keep doing that till it gets close, but it does it faster than we can. So we're going to go up top and go to the formulas then. We're going to go to the data tab up top. We're going to go to the forecast. We're going to go to the what if analysis. We're doing some what if analyzing here. And then goal seek. And then we're going to say we would like to change this cell. We want to change that cell to be what we know it should be. And you have to hard code it or type it in here. $1,000. That's what we need it to be by then changing this cell. So then I'm going to change that cell. So once again, we want Excel to change this cell to $1,000 by making this cell whatever it needs to be. So we're going to say, all right, let's do it. Do it, Excel. And there it does it for us. And we're going to say, okay. And so you can kind of see how all these are kind of related, right? We use the rule of 72. We use the running balance. We use the future value, the present value. We're getting the same results here. Now, you can also say, well, instead of using this kind of backwards method to back into this unknown by using goal seek, why isn't there a function for that number of periods? You could look for the function for the unknown that you don't know and try to do it that way. And there is usually a function if you think about it that way as well. So I'm going to say, all right, let's use the number of periods. I'm not as familiar with that function because most likely I'm going to get to know the present value and future values first. But let's go ahead and use this function, right? And so I'm going to say, all right, let's look for that. Let's find it. Let's go up top and say formulas, functions. And then I'm going to say, well, that one was the number of periods in PER. There it is. They do have one. I knew they would. Returns the number of periods for an investment based on period constant payments. Okay, so let's do it. This is the most direct one, which we did last because it's probably the least well-known one that you would use. So I'm going to say rate. So I'm going to pick up the rate once again up to 7%. The payment, just like the other formulas, there's no payment there because that would be for an annuity, and this isn't an annuity function. So we're going to go to the present value. We do know the present value, which is our starting point before it's going to double to 2,000. That's going to be the 1,000. And we also know the future value. That's where we want it to be at the end, which is at 2,000, which I would like to do by not hard coding 2,000, but rather taking the 1,000 times 2 to get to the 2,000. Note that it doesn't give us a result down here because Excel wants a negative number, and this is where it gets kind of confusing. I won't get into the logistics of why it wants a negative number there, but notice if it doesn't give us a number and it gives us like an error, usually the payment function, that's where Excel wants the negative number. So if I make that negative, it then gives us our result, which can be a little confusing. So there we have it. I'm going to say okay. So there it is at the 10.24, the most direct way to kind of get there as well. Let's go ahead and delete that and do it one more time with our function. I'm going to do it this way. Equals and the way I know what this function is, once again, it's because I can see the unknown when I did the future value. So even if you don't want to use goal seek, you can use future value and say, I know this is the unknown right there, and it's called by Excel in PER. So most likely they might have a function called equals in PER, number of periods is what that stands for. So we're going to say, all right, let's try that. Equals in PER. There it is. They do have it. Double clicking on that. The rate, we're going to pick up the rate in this argument, which is going to be the 7%, not typing it in there, not hard coding it, but picking it up from our data set, comma. The payment amount, there is no payment because that's related to an annuity if there were a series of payments. So you can either put 2 commas or you can do that 0 and then a comma as a placeholder. The present value, that's where we start at when we're looking at this kind of system. We're going to say it's going to be the 1,000 and then comma The future value is where we're going to end at, which is going to be doubled, or 2,000, which I don't want to hard code by just typing in 2,000, but rather pick up that 1,000 times 2. And so there we, and then let's close it up. And so there we have it. And notice it gave me a wrong thing because it's what I always do. I did that on purpose, by the way, kind of. So if I go on, notice it gave me an error, and that's because I got to put one of these as a negative. I can't just put a negative in front of the n here because it didn't give me a negative number. I actually have to go in here and put the argument that it wants as a negative number, which is this present value. Otherwise, it won't work. So I'm like, all right, Excel. If that's how you're gonna be, put a negative before the B8 and enter, and there we have it. And so there we have it again. So that's gonna be these ideas. If I unhide this, if I go to the B again, and I'm gonna go back to L, I'm gonna go from B to L, right click on those, and then unhide. Notice we've looked at the rule of 72 and found this, but that's very limited. Notice that this second way of doing it is quite useful because now that really gives you a lot more detail as to what's actually happening, how the interest is compounding. You don't get to see that even when you're doing these future value kind of calculations. When people use and understand present value and future value in Excel, they often still have no real comprehension in their mind what is actually happening to the interest. It's just a magic number that basically pops up. This running balance, quite useful. Next time we'll do the same kind of thing, but we'll do it with formulas for the present value formula and the future value formula, and then we'll do the same thing using tables. Now these other two ways are not what you would probably do in practice as much because it's more tedious to use formulas if you have access to something like Excel or a financial calculator, but they can be useful in a book problem. You will often see these tables, and no matter what formula or way you want to look at this, what you really want to do also is be able to say, hey, if someone's doing something in some funny way, they're using formulas, they're using Excel, they're using the rule of 72, that you're not like, oh, there's some magic wizard doing something totally different, I don't know what they're doing. No, they're just doing some whatever way, same thing, they're just doing it a different way.